Hello. In this video, we introduce truth tables and we build on our knowledge of logical statements and connectives and the notation that we learned in our last video. Let's get started. So recall that a conjunction P and Q is true when both P and Q are true. So our first fill in the blank is both. So for an and statement to be true, if someone says, I am 20 years old and I like the color blue, in order for that statement to be true, I have to both be 20 years old and also like the color blue. If one of those is false, then it is a falsehood. So there's one other symbol that we learned in our last lesson, and that was the or symbol known as a disjunction. Remember, that was the V-looking symbol? And we say that P or Q, the disjunction P or Q, is true when at least one, so at least one of those two statements, P and Q, are true. So again, for example, if I said, I am 20 years old or I like the color blue, as long as I'm at least 20, as long as at least one of those is true, so I'm either 20 or I like the color blue, or maybe I have both that are true, then that would be a truth, okay? So an or statement only requires that one of the two simple statements is true, whereas an and statement requires that both of them are true. Let's look at another practical example. Suppose that P was this mathematical statement, 2 plus 3 equals 5. Now you can already tell, I hope, that that is a false statement. Good job. And let's look at statement Q as the simple sentence, Christmas is in May. Now you might celebrate Christmas in May, right? But typically Christmas is not found in May, but rather in, right, that's right, in December, right? So in this situation, we would say that the statement P and Q, which says 2 plus 3 equals 5, and Q, which says Christmas is in May, would be false. Now, why is that? Well, in this case, it would be false if I had changed this sentence, and let's put December just to have a little bit more fun for your next example here. So go ahead and take your notes and cross out May and put December with me. If the statement Q now is Christmas is in December, now that's true, right? But notice that the statement P and Q is still false. Why? Because the first statement was a falsehood, and both of them had to be true. What about the statement P or Q in this new context, where I have P is 2 plus 3 equals 5, and Q is Christmas is in December? Well, this would be a truth now, wouldn't it? Because at least one of them is true. But if we went back in our notes and we looked at the original statement Q, Christmas is in May, this would also be a falsehood, wouldn't it? Because in that case, both P and Q are false, and at least one of them had to be true in order for this or statement or this disjunction to be true. Now, in those two little examples, you already should have known that 2 plus 3 was a false statement and that Christmas is in May was a false statement, right? However, when we're talking about preferences, like Joe likes football, we may or may not know if that's a true or false statement, right? So when we don't necessarily know if our simple statements are true or false, what can we do to list all of our possible outcomes for this compound statement? Well, what we would do is we build something called, or we construct, a truth table. That would be our next blank to fill in, table. So a truth table is just a list of all possible outcomes or truth values when you're combining two or more simple statements with connectives. So how do we begin? Well, let's show you an example of one that's already pre-built, and then we'll build some together. So in this example below, we see a P column, and that's going to be pretty standard. For every simple statement that's in your compound statement, you will have a column, right? So P gets its own column and Q gets its own column. And if the statement that we're trying to build a truth table for was, let's say, P and Q. So we want to know under which conditions would this conjunction be true and which conditions would it be false. So what I recommend is, if you're visual like me and if you like using colors to help you, pick a color that you always will like for your truths and pick another color that you'll like for your falsehoods, just so you can kind of see it pop a little better. So for example, in this video, I'm going to use blue for true and red for false. So let me show you how they built this, okay? So what they did is they said, well, statement P could be either true or false. And that means there are two possible outcomes for statement P. Statement Q could also be true or false. That's another two possible outcomes. And if you remember from a previous chapter, when you're trying to figure out how many possibilities there are, you can multiply, right? 2 times 2 gives you 4. That's why we get 4 rows, okay? And the more simple statements, the more rows we'll get. We'll talk about a formula on the next slide. So what we did is we actually said, well, P could be true, while Q could also be true. So this would be the case where both of them were true, like the case above where we were talking about someone who is 20 years old and at the same time they like the color blue. If those are both true, then that would be that situation. Okay? Another situation is where the first statement is true, but the second statement is actually false. So that's another possibility. Okay, so we've exhausted the two possibilities when the first statement P is true. But we also know that P could be false. So the first statement could be false, while the second statement could be true. Okay? And there's one other possibility. Can you think of it? Well, it's right there. It kind of helps us, doesn't it? The first statement could be false, and so could the second statement. Okay? So those are the four possibilities when you're talking about a simple statement where we've taken P, and a simple statement we've taken Q, and we've joined them together with one connective, like and. So what happens now in the truth table? Let's take a look. So in this truth table, we notice that we had mentioned here that for a conjunction to be true, right, they both had to be true. They both had to be true. So if they're both true, then this is a true statement, P and Q. And that happens in the first case, doesn't it? Because both P and Q are true. But notice it does not happen in any of the other three cases, right? We have one falsehood or two falsehoods. So in those three cases, the result is a false statement. So under one condition, when they're both true, the whole statement is true. But in the other cases, it's always going to be false. Okay? Now what about instead if we had said P or Q and we wanted to make a truth table for this compound statement? The first thing we would have done, again, is have a P column and a Q column, just like we already started with. And then we'd ask ourselves, under what condition is a disjunction or an or statement true? Remember what the note said above? It's going to be a true disjunction when at least one of them is true. So if you see at least one truth when you're talking about P or Q, then this would be a true statement. So in my first row, is this a true statement? Yes, because at least one of them is true. So that's a truth. Second row, again, one truth because P was true. So that's a truth. Third row, that's right, also true because Q is true. And finally, the last row. Well, the last row in this case is going to end up being what? That's right, false. Why is it false? It would be false because there is not at least one truth. So this would be a falsehood. Okay? So this would be the column for this type of compound disjunction. One more we can practice. We learned this notation last class in our last video. And it was the negation symbol. So that's when it's saying not P. So in the case of P being the statement, I am 20 years old, then not P would be I am not 20 years old, right? So when would that statement be false and when would that statement be true? Let's take a look. So in the first case, if we're looking at not P, what do we need to do? Okay, we never made a column like this on a truth table before. To negate something, it means take the opposite, right? It's like a negative sign when you're dealing with math, typically. So let's see, what's the opposite of the P column in this case? The opposite of this T, is an F. That's why we put an F here, okay? And the same thing happens in the second row. The opposite of P is an F, okay? But what about the opposite of an F? What would that be? The opposite of false? That would be a truth, and that's what we see happening here. We see we're getting a truth for the other two. Let me move this toolbar for you. You can see that more easily. So we have our truth here. And why is that? Because we took the opposite of a falsehood and the opposite of a falsehood. That's how we got those truths. Okay, so I would encourage you to take a moment and make sure your notes are really strong for how this truth table went and why before we head to our next slide. Okay, if you're ready, here we go for our next one. So in this slide, we're now going to build our own truth tables from scratch. All right, so here we go. First of all, let's take a look at the first example that they're giving us. Let me move this tool cup a little bit. There we go. So in the first case, they're giving me the following. They're saying we have this statement here, in parentheses, P or negation of Q. And then what do they do in front? Then they put a negation in front. So we're saying it's not true that P or not Q happens. Okay? So in order to build this, what we want to do first is ask ourselves, how many simple statements do we have? And then we'll build the compound one. Okay? So in other words, how many letters do you see? How many unique letters do you see? Like P, Q, R, S, T, etc. I only see 2 unique letters. Do you? So that's why we're building one column for P and one column for Q. Now, do you notice that in the truth table to the right of that, we have a lot more rows than just 4 rows? And why do you think that is? Well, that's because that's a compound statement with a P, a Q, and an R with 3. And if you want to count, how many rows did I build here for your template? 1, 2, 3, 4, 5, 6, 7, 8, I hope? All right. So one had 4 when we only had 2 simple statements, and now we have 8 when we had 3 simple statements. And I bet that if we had 4 simple statements, like an S thrown into the mix, then we would have 16. Would that be right? So what's happening? If you think, well, we're multiplying by 2 again, you're right, because for each new simple statement, there are 2 possibilities, right? True or false. So 2 times 2 times 2 gives us 8. And if I had 4 of them, it would be 2 times 2 times 2 times 2, or 2 to the 4th power, which is 16. All right, so what is the formula here? If there are n simple statements, so in this case there's 2, so here n equals 2, and here n equals 3, right? If there are n simple statements in a compound statement, then there are 2 to the n, so that's 2 raised to the power of n, not 2 times n, rows in its truth table. Okay, so in this case, 2 to the n would be 2 squared, or 4 rows. And in the second case, we'd have 2 to the 3rd, which is 2 times 2 times 2, or 8 rows. Okay, that's the idea. So once we know how many rows there are, then we can start building our table. Now, some students, I will tell you, they'll just pre-print a lot of these templates for themselves so they don't have to keep writing them over and over again. And if that's something that you think would help you, then go ahead and do that. Okay, so how do we begin after we have written a P column, a Q column, and we have 4 rows there? Well, let me get my color for blue, which was my true color, right? Remember the pattern. Half true, you might want to write this down. Half true and half false will always be my first column. Half true and half false. So I'm going to do true, true, and then I'll switch to my false color, which I chose as red. False, false. Okay? Half true and half false will always be my first column. You can even go to your bigger truth table to the right and also do the same thing right now, but you'd have, instead of 2 and 2, you'd have 4 and 4, because half of 8 is 4. Okay, let's continue with our smaller one though. Then we would begin with the Q column. And so what did we do last time? Feel free to look at the last slide if you need to. We now cut that number in half. So if we went 2 by 2, now we go 1 by 1, oscillating. So I'm going to go true, then false, true, then false, so that I've listed all the possibilities. Now you might be asking, do you have to do it this way? This is kind of confusing, you're thinking. No, you technically don't, but this is the standard or the traditional way that we do this in logic. So if you want to be in the same place as your online homework sites or your textbook, you're going to need to get used to this pattern. So remember, first column, half true, half false. Second column, we take half of the last number, so which was 2 by 2, and now we go 1 by 1. Okay. Now that you have the basic template for the P and the Q column, we are going to practice building out our compound statement. So where do we begin? Let me grab another color like black, why not? Okay, so what we want to do is notice that inside the parentheses is where we want to start, okay? And inside the parentheses, if you see any negations, that's what we want to typically do first. So I have this negation of Q. I'm going to make a column for that, not Q column, okay? And then after I do the negation of Q, I'm going to do what's in parentheses then, P or not Q. And then finally, I'm going to take the opposite of that. So I'm going to write the whole thing. Negation, parentheses, P or not Q. So that's going to be my setup. And now we can actually fill in the rest of the table by using what we've learned in our previous slide. So let's go real slowly together. For our first column, the not Q column, remember what that does? It takes the opposite, that's right. So since we're taking the opposite of Q, we just look at the Q column and we ask ourselves, what is the opposite of this first value in row 1 here for Q? It was a true, so now it's a false, and this false now becomes a true, and this false down here, the 4th one, is also a true, but the 1st and the 3rd are now falsehoods. So let me get my color for falsehood, which is red. So the not Q column should read FT, FT. Okay, now I'm ready to build my parenthesis column, P or not Q. Now what I like to do is maybe grab another color here and tell myself visually which 2 columns I'm uniting together with the disjunction or. The column I need to look at is the P, it says, so this column here, and the not Q column, right? Those are the two that I'm looking at for this part right here, okay? P or not Q. So I'm looking at those two together now, P or not Q, and the connective is or. Remember what or means? At least one of them must be true in order for the statement to be true. So I'm going to look carefully for some truths. Do I see at least one truth when I compare P with not Q? So let's look at the first comparison. True is my P, false is my not Q. Is at least one of those true? Yes, so this would be a true statement. Let's do the next row. P is true and not Q is also true. Well, is at least one of them true? Yeah, in fact, they're both true. So that would be a truth. Notice, though, in the third case, we have a problem, don't we? Not necessarily a problem, but if you're looking for truth to be a good thing, then this is not one of those times. Because in this case, we have a falsehood for P and a falsehood for not Q. So this whole statement, because we need at least one to be true in order to be true, is a falsehood. And the last one, however, has a falsehood and a truth, so this is a true disjunction. So the only falsehood that we need to put with my red color here is the third row. Do you see why? Make sure you're comparing the right columns here, the P column and the not Q column. It's really easy with our eyes to look at the wrong column. Finally, the last thing we want to do to finish off this part of the problem, let me get another color here, okay, is to take the negation of parentheses P or not Q. Take the opposite of that column. So what was that column? Well, that was the column right before here, wasn't it? So how do I take the opposite of something? Well, I say if you were true, now you're false, and if you were false, now you're true. So we have a lot of falsehoods, don't we? Because this truth is now a falsehood, as is this truth, and the last truth in row 4 is now a falsehood. And there is one that becomes a true statement, and that was the one that was previously false in row 3. Okay, so the truth table here is now complete because we have the final column representing when our compound statement that we were asked about is true and when it is false. This will have significant importance as we move on, not only in these sections, but going forward as we build out our logical arguments. We'll be asking questions like, is your statement always true? Is your statement always false? And we'll talk more about that in a few minutes. Okay, so that would be the final column for that truth table. Let's see if you can pause the video and try the next one on your own. Okay, let's see how you did. So what you would have started with is asking yourself, how many simple statements or letters do you see? P, Q, R. So you want a P, Q, and R column, 3 columns. 2 to the third power is 8 rows, so that's why we have the 8 rows ready. And how did we start off again? The first column is always half true, half false. That's right. So hopefully you gave me 4 truths followed by 4 falsehoods in the first column. Let me grab my color red for false. Okay, so the P column is 4 truths and 4 falsehoods. For the Q column, what did we do last time? That's right, we cut that number in half. Last time it was 2 by 2 and then 1 by 1. Now it was 4 by 4, so now we'll cut 4 in half and get 2, right? Good job. So let me grab my blue for true. So 2 truths followed by 2 falsehoods, followed by 2 truths again, followed by 2 falsehoods. So it's TTFF, TTFF for the Q column. And what do you think we'll do for the R column? Any instinct? Maybe you already did it on your paper. You want to see if you're right? That's right, you cut in half another time. So instead of 2 by 2, cut 2 in half, you get 1. 1 by 1, always starting with true, right? That's the convention, right? So we're going to go true, false, true, false, true, false, true, false. And trying to keep my color coordinated system here for you, if that's helpful. Okay. Now that we have our template built, and again, as I mentioned, some of my students will actually pre-print these for themselves. They'll create them, they'll pre-print them so they don't have to redo these every time. And you are welcome to do the same. All right, so what do we want to do next? Well, next we're going to build out from the small inside parentheses to the large, right? So we say, okay, I see here that we have a parentheses, R and Q, but there are no negations inside that parentheses, so that can get its own column right away, R and Q. And then I noticed that after the and connective, there's another simple statement, and it's not P. So I'm going to need a not P column. And then I need to put the two together. So this is like the last thing I do. So I did this first, I did this second, and I did this third. Now, do you have to do it in that order as far as columns go? Not necessarily, but what you can't do is you can't jump right to the whole statement. You have to build your way there, okay? So the last piece would be taking R and Q and then and not P. And make sure you copy it correctly. All right, let's see how you did. And again, feel free to pause the video if you just need help with the setup and now you want to try your best on your own. Okay. R and Q. So again, what did I do? Well, I recommended looking at the R and the Q column, so that's these two, and you're joining them with the connective and. And what had to be true for an and statement, that arrow going up? They both had to be true. That's right, in order for the statement to be true. So R and Q. Now in this case, it doesn't matter if you look at the R first or the Q first, right? For the and, it really doesn't matter. It will matter when we have the arrow. That'll be in our next video. But for the and, the order doesn't matter. So as long as they're both true, we're good. And that is the case in the first row, isn't it? They are both true. So this is a true statement. Does that ever happen again? Are they ever both true again? Not until it looks like the fifth row, they're both true again. The rest are always false because we don't have both truths. So false for the second, false for the third, false for the fourth, false for the sixth, seventh, and eighth. Okay. Then I would do my negation of P column. Make sure you pick the right one. I said Q by accident. Negation of P column. In order to do that, we're going to look at our original P column and take the opposite. Good job. So instead of 4 truths followed by 4 falsehoods, what should I do? That's right, 4 falsehoods followed by 4 truths. So I'll jump right here since I have blue already. These last 4 falsehoods are now going to become truths. And the first 4 truths will then become, I'll make them red here for my convention, falses. Okay. All right, one last thing we have to do, and then we'll have the entire statement, okay? We need to put together the R and Q column, which was right here, with the not P column, which was right next to it on its right, and we're joining them together with the connective and, another conjunction. So again, a conjunction is true if both of them are true. So let's look at our first comparison. We'd have a true with a false. Are they both true? No, so that's a falsehood. In fact, you can do a quick scan all the way down. Do you ever see these 2 columns both true at the same time? I see it happening one time down here in the 5th row. Everywhere else, I don't see it happening, so it's a falsehood. So I'll get my falsehoods out there, out of the way, and then write my only time this is true is in the 5th case. So that's the only time where that statement would be true. In every other case, it would be false. So again, this would be our final statement, our final column rather, of the statement in its truth table. Okay, one other thing on this slide before we have you do more practice, and that is if the final column of the truth table for this compound statement, if it was true in every case, which definitely did not happen in my 2 examples, right? They were almost always false. But if it was always true, we have a special name for that, and that name is a tautology, not a trilogy like a lot of my students think I'm saying. Tautology. So it's T-A-U-T, that's taut, O-L-O-G-Y. Tautology. So a tautology is a compound logical statement which is always true. And you might hear people talk about that in real life. They'll say, oh, that's a tautological statement, meaning that's a statement which is always true. Okay, so let's head over to our next slide and put some of these skills to practice. In example 1. So the difference between this example and what we've previously done is in the past, I gave you the statement in logical symbols like P's and Q's. Now I'm giving you an English sentence, and you need to translate it first and then make your truth table. So it says, write the statement symbolically, so with your P's and your Q's, and then construct a truth table to determine if it is a tautology. Feel free to look at your notes again or write that in the corner. That means always true, a statement which is true in every case. Okay, let's see what this English sentence says. It says, I am hungry and want to eat healthy, comma, but I am in a hurry. Okay, so I'm hungry and I want to eat healthy, but I'm in a hurry. Remember that the word but is the same as and for logical purposes, okay? So how would I write this statement in logical symbols? See if you can do it yourself and then we'll compare. Well, if you let the first statement be P, I am hungry, and the second statement, Q, be I want to eat healthy, and the third simple statement, R, be I am in a hurry, then in logical symbols, this would be P the and conjunction, which is the arrow that looks like it's pointing up, P and Q. But what did this comma tell me? Do you remember what that meant? That meant everything that comes before it is together, and everything that comes after it is another idea that's by itself. So P and Q needs to go in parentheses simply because of that comma. So pay attention to those commas. They mean something. So P and Q is in parentheses, but just means and, so we're going to use our connective again. And then I'm in a hurry was statement R, we said. So this is the logical statement in symbols. So we've written it symbolically. Good job. Now, if we look at the statement, can you build your truth table? Maybe pause the video and try it yourself. All right, so you have your P column, your Q column, and your R column. Which other columns are we going to need if they hadn't helped us out? That's right, we're going to need the parentheses, P and Q. Do I need to write an R column again if I already have an R column? No. So I'll just need my last one, P and Q in parentheses, and then and R. Okay. So let's see how this is going once you've filled it in. Feel free to pause the video and then come back. So half true, half false. Why do I have 8 rows again? Because I have 3 simple statements, 2 to the 3rd power. Good job. So 4 truths and then 4 falsehoods for P. For Q, how do we do it? 2 by 2, right? So true, true, false, false, true, true, false, false. So true, true, false, false, true, true, false, false. Let me grab my colors here. So T, T, F, F, T, T, F, F. All right, and then for your R column, instead of 2 by 2, we went 1 by 1. So true, false, true, false, true, false, true, false. Let's fix that here. True, false, true, false, true, false. Okay, so now that you had your basic template, again, feel free to make copies of those and just not have to write it each time. For P and Q, we are comparing the P column with the Q column. That's right. So for P and Q, we're comparing the P column with the Q column. And how are we comparing them? With which connective? The and connective. So for an and situation, the statement is true in which case? When they're both true. That's right. So does that ever happen? In our first row, does that happen? Yes. In our second row, does that happen? Yes. Anywhere else? No. So in the first 2 rows, that would be a true statement. Every other time, that's a false statement, isn't it? Okay. And finally, to finish this one off, to build the entire statement out, the compound statement, we take the P and Q column, which we just had, and we unite that with the R column. Those 2. And we're comparing them again with and, which meant they both have to be true in order for the statement to be true. Does that ever happen? Well, yeah, in the first row, we see them both being true, don't we? So that is a true statement in that case. Does that ever happen again? Looking down, I do not see that happening again. So again, those would all be falsehoods. Only the first case would make this a true statement. All other times, it's a false statement. So is this statement always true? No, it's almost always false, isn't it? So this is not a tautology. When it asks you, is this a tautology? No. In fact, in a future video, we'll talk about another special name to watch out for, which is a statement that is a self-contradiction, when everything is false all the time. It's a statement that always contradicts itself. Anyway, this is almost a self-contradiction, but because it is true in one case, it's not. All right, let's try our last example together. Try it on your own and then compare with me. Example 2 says, can you write the statement symbolically and construct a truth table to determine if it is a tautology? All right, so let's see how you did. First thing I would do is write out which simple statements I see. I worked all week. I'd call that maybe statement P, right? But, that's my connective we know about. I have not been paid. So let me erase the not part for a moment. I'm going to let I have been paid be statement Q. So how would I join these 2 together? I would say, yep, that's right. P, I worked all week, but is like saying and, right? So and I have not been paid, so it's the opposite of being paid, so negation of Q. So we're going to try to use this statement here in our truth table. Now, if you're wondering, wait a second, Professor, why didn't you talk about the comma like you did last time? Great question, great thought. The comma is telling us that everything before it is one idea. But notice here we only had one idea to begin with, so there was no need to group multiple ideas together with parentheses. See the difference? Okay. Now let's take a look at our truth table. How many rows do I need if I only have 2 simple statements, P and Q? Well, 2 to the second power, which is 4, which is what we see here. So if you haven't already done so, pause the video and see how you do with your setup here. All right, so to begin with, I did half true, half false for my P column. True, true, false, false. And then for my Q column, I did 1 by 1, right? True, false, true, false. So true, false, true, false. And then to continue to build my compound statement, remember we have to start with anything in parentheses, which we don't have, and then any negation symbols. We do have a negation of Q there, don't we? So that's what I'm going to put next. My negation of Q column will go next. Negation of Q. To negate Q, what did we do? We took the opposite of whatever that column was. So make sure you pick the correct column when you take its negation here. So the opposite of TF, TF is FT, 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 FT. Okay, and finally, the next thing we want to do is combine P with not Q. So let's do just that. P with not Q. That's going to be our final statement, P and not Q. If you wanted to put it in parentheses, you're welcome to, but there's no need here because you're not doing anything beyond just combining the two together. All right, so P and not Q. We're connecting them with the and, which requires what again for it to be true? It requires both of them to be true. Very nice. So do we ever see this column true at the same time that this column is true? One time, don't we? It's right here. True and true. Okay, so that's the only case where that is a true statement. In every other case, it is a false statement. Is this a tautology when I look at its final column here? Is it always true? No. In fact, it's almost a self-contradiction, which we'll learn about in a future video. All right, well, in this video, we've gone over a lot. We've talked about how to set up a basic truth table. We've talked about how to check when an and statement or an or statement is true and how to use negations. What I would highly recommend is you make note cards and make sure that your notes are very nicely done in order, where you have examples next to them so that you're in a really good spot as we build on these skills in our next video. Until I see you next time, happy practicing. Math is not a spectator sport. See you then.